little excitement, that's okay. I'll accept it. So this week, well, I'll get to that in a minute. But next week, let's talk about next week. We have Ben Glick coming to us and talking to us about the importance of UX to back-end development. So that'll be nice and a good one. Don't have any announcements today, other than the fact to introduce our speaker all the way from, is it Bangalore? Yeah? Is it a 12-hour time difference?
Sorry?
Is it 12 hours? Or is it midnight there?
I can't really hear you.
Is it midnight?
No, it is 9:40 p.m.
Okay, my time zones are off. Shocking. All right, so yeah, so Katie here helped make the connection here through Mozilla, and yeah, hey, yeah, there you go. And Srushtika does works with VR, web-based VR, and that's what she's going to be talking with us about today. And so you all give her a warm round of applause.
Am I good to start? Okay. Hey, everyone. Good to see you all have lunch. I just had my dinner. Okay, so I'm going to share my screen. Give me a second. Okay, can you see my screen? Perfect. I'm sorry, can you see my screen? Okay, great. So I'll be talking about web-based virtual reality made terribly easy. So I'm Srushtika Neelakantam, as introduced by Brett. So I'm a Mozilla representative, a tech speaker, as well as a campus advisory committee member. And most recently, I've co-authored this book titled Learning Web-Based Virtual Reality, which is published by AFrame. It is available on Amazon if you want to buy it after this talk. So what basically is virtual reality? Most of you might have heard of it or even experienced it. It's pretty common as of today. So it basically refers to the creation of immersive three-dimensional experiences, simulation experiences around you, which is really very much close to actual reality. Now you get to play, move around, interact with all these objects, which are virtual and which are present in a particular scene. Now, when I say scene, it is the SCENE. And whenever we are talking about virtual reality, whatever you happen to see at a 360 degrees angle around you, we call that one particular scene, right? Now, as you can see from the visual playing behind on this particular slide, it's amazing to see a vast range of things that we can do with VR, right? So it's not just entertainment, it's not the gaming that is a pretty preconceived notion that VR means gaming, but there are a lot of other things like education, learning, and art that you can probably do with VR. So we can be right where we are and still be somewhere else with virtual reality, right? Now, how do you access virtual reality? So basically, virtual reality can be accessed by one of these headsets, which you see on the screen. So these headsets vary in range in terms of price. For instance, the Google Cardboard that you see on the top left is just a DIY kit made of cardboard that you just stick around, which allows you to place your phone on it and experience a first-hand, basic VR experience. So it is available for around just $5. Whereas the HTC Vive that you see on the bottom right corner is around $800. Now, why this differential price ranging? Definitely because of the features and the experience that they give you. Now, okay, at any point of time, if I'm not audible or I'm not clear, please tell me, because I can't see the audience when when I'm showing the slides. Is that fine? Okay, okay, great. So, So again, these VR headsets are also categorized in terms of tethered and untethered headsets. Now, what are tethered headsets? These are wired headsets. A wire is connected to your headset, which you put on your face, and the other end of the wire is connected to the computer desktop, which is responsible for generating the content that you experience via your headset. That is called a tethered headset. Whereas there are other class of headsets which are untethered. So what happens in these untethered headsets is basically you have a mobile device which itself generates the content which you view as VR when you put on the headset. Or it may also be that your VR headset itself has an inbuilt screen and an inbuilt operating system that generates your VR content, right? Now, as you can also see from these VR headsets, there are different types of controllers available with these headsets. Now, these controllers may be Bluetooth controlled uh, controllers, which let you add interactivity to your scene. For example, I have a scene in which there are Lego blocks kept on the floor, and I would like to, pick one block and place them at a particular place. So these remotes allow you to do such things in a VR scene. Next, we definitely have some friction in the current VR ecosystems. Let's explore what those are. The current VR ecosystems have a lot of gatekeepers, right? Now, what I mean by gatekeepers is, for instance, I'm an Android developer and I would, like to develop a VR app and publish it on the Play Store and want my friend to view it and experience the VR app which I built. What happens there after I submit it on the Play Store? There are reviewers out there who would review my app and decide whether to make it available or not available on the Play Store for use by others. Now, I don't like such gatekeepers. I have built an app which I would like to share. So that's friction. Next, we have installs. Now, imagine we didn't have gatekeepers. There were no, people who would review your app. As soon as you built it, you were just uh, allowed to share it with people and make it available on the App Store. You still have to download it and install it, right? And VR as such includes a lot of graphics and it's worth hundreds of megabytes of space. So for someone like me who likes to click a lot of pictures, my memory is almost full with all these pictures. So I don't really have space to install 100, some 400 MB worth of VR app just to experience it for once, maybe just to see what it does, right? So that's friction again. And the worst part is it is closed. So all the VR ecosystems right now are closed source. It's completely like a black box for a developer who wants to get involved and explore the world of virtual reality. You don't get to know how things work currently. So how can we solve this? Introducing WebVR. What is WebVR? It is an open virtual reality platform now with the advantages of the web. Now, when you include web, there are tremendous advantages compared to its traditional counterparts, right? Now, basically, the goal of WebVR is to make it easier for everyone to get into VR experiences, no matter what device you are on. So, for instance, you're on laptop and you want to build something for VR, you don't necessarily have to go to the mobile to test it out. You can do it right there. And if you have mobile, you don't have to build a separate one for different operating systems or different kinds of mobile devices. It's just one thing that you do and it is available on the web. And when I call web, it is the VR that plays in your browser. Now it plays in your mobile browser, it plays in your desktop browser, in whichever device that can have a browser basically. Now, what are the advantages with having WebVR against the traditional VR that we talked about earlier? So basically, it is completely open source. As I said, it is an open virtual reality platform. Now, uh, I'm sure I'm talking to mostly developers right here, and I don't have to explain what tremendous advantages we get when something is open source. We get access to the source code of it. We can play around with it, and we can do our own experiments and also submit our own makes for people out there to use. Next, it is completely connected. Now, imagine a website that has these web pages. How do you navigate from one web page to the other on a website? You just hit a particular URL and use the href element of the anchor tag in the HTML, and that's how you navigate from one page to another. So in this way, every web page is basically connected to every other web page on the web. Exactly this way, since WebVR plays your VR experiences in the browser, every VR scene that is what I explained earlier, a 360-degree sphere. Every such sphere is connected to every other sphere in your using your WebVR. So you don't have to come out of something to go into another thing. It's all connected. Next, and the best part is it's instant. You don't have to download anything, you don't have to install anything. It's just a URL you hit, like you hit it to reach any other random website. You just hit a URL and there you have the WebVR experience right there in your browser. You don't have any other, additional plugins or additional applications which you require to have in your phone. And you can just, put your phone inside a cardboard or a similar VR headset and experience the VR right there. How cool is that compared to other traditional VR ecosystems we have right now? Now, WebVR is basically these browser APIs that enable web graphics library rendering to the headset. Now, what they do is they access the sensors on your mobile device, or maybe which are directly inbuilt on your VR headset. They get access to these sensors and use it in such a way so as to let WebGL create the content according to those parameters. So what I mean by this is, for instance, I'm wearing a headset and I turn towards my left. So what happens is the content in front of me is changed. So I now happen to see what's actually towards the left in the 360-degree 3D sphere. I don't really, see the same thing as we do in normal websites, right? Okay. So with WebVR now, since it is really newly conceived by Mozilla in the spring of 2014, the work has been tremendous in WebVR, and there are a lot of other companies also working on WebVR. I'm not sure if you had heard about WebVR on Google I/O, but there was a talk on this, and there are a lot of companies working on WebVR. So the support for WebVR right now is limited to only these browsers, but for those browsers who don't yet support WebVR, there is something called mobile polyfill. I'm sure most of you know it, but a mobile polyfill is just a piece of code that lets a particular browser, which actually does not support WebVR, mimic the functionality of having to support WebVR in the browser. So even if it is not one among this list, the browser which you use, you can still use it to play your WebVR scenes in the browser using something called mobile polyfill, which is really good. And probably while I'm talking to you right now, they are building support for the next in-demand browser out there on which you can play WebVR. So that is how fast-paced things work with WebVR and this technology in general. But what all I have been talking about WebVR is basically that traditional VR is now replaced with WebVR, which basically means that you can play VR in your browser. Is it just that the advantages of the web that we have got make it easy? No, it is still hard to create WebVR experiences, right? So why did I have to name my talk "Made Terribly Easy"? It's still hard for me, even to make the most simple hello world scene in a VR. I have to do so many things. I need to import the WebVR polyfill, set up the camera, set up the lights, initialize the scene, and a ton of other things, which is mostly boilerplate code involved in WebVR, right? So what is easy in this? Well, introducing AFrame. AFrame is a declarative framework that was developed by Mozilla. It allows you to get unlimited access to the JavaScript and 3JS, which WebVR uses. It lets you get unlimited access to it while limiting the code you have to write to just HTML. Now, for me, I studied HTML in my high school, and I think it's the easiest language any web developer can find on his toolkit. So it's just HTML and occasionally CSS and JavaScript according to the application that you're trying to build, which should be really, really easy. Also, what exactly AFrame does is it wraps the power of the web graphics library using HTML custom elements. So there is this JavaScript script that is released by the makers of AFrame, which is the Mozilla VR team. So you just need to include this script as a source in the script tag in your HTML file, and you're good to go and are allowed to use a ton of new HTML custom elements, custom tags, using which creating VR is just a cakewalk. Really, really, it becomes easy. It's like any other tag. For instance, you have the paragraph tag inside which you write a paragraph in usual HTML websites. So what basically happens, you just add the tag and write the content. Exactly, it is so using AFrame. And what support it has with the other other items in the web developers toolkit. You name it, like D3, Vue, React, Redux, Angular, jQuery, all the popular JavaScript frameworks that usual web developer works with. It is supported by all these. It is compatible with all these frameworks basically. So if you navigate to this website, aframe.io, which is the official website for the AFrame framework that I've been talking about, you can see all these different kinds of examples that people have built using AFrame, which is very, very easy. So you can see it's not just basic code. Basic elements that exist, but you can actually build the VR experiences that look like a sophisticated game, which you usually think of when you hear about VR. Now, I've been talking about a lot of all this theory, like in a theory class. So we are developers, and we definitely want to see some code, right? So here's something. Now, let's try and build a Hello World application um, in a VR using AFrame. Now, as I said, it's just plain HTML, and I'm sure you identify with all these tags. So HTML is written in the starting and ending of the HTML tag. And as I said, you need to include this particular JavaScript in the script tag of the HTML. And like we have the body tag in a usual website for when you build a basic website, and you write all the elements that you want inside the website between those opening and closing body tags. Similarly, for a VR, you write all those contents which you want to be included in one particular scene inside these two tags called a scene. Now, these a scene are definitely not the usual tags that you come across when you think about HTML, but when you include this script, as I said, these custom made tags are available for you to use, which are powered by AFrame, of course. So let's think of it. Now, for a hello world, let's probably imagine a scene that contains a box, maybe a sphere, a cylinder, and a plane with just a plain background. So let's not go with sophisticated looking VR scene as of now, because we're just get starting to get into it using Hello World, right? So what happens if we want to build such a scene? Would it be like some 2 to 3 pages of code? Let's see. So this is all we need to do to have what we thought. So it's just a box, which lets you have a box in VR, and then you give the values to its attributes, just like that, like you do for any other HTML tag. So there's a box and the color attribute, position attribute, rotation attribute. And position attribute, by the way, is the XYZ coordinates of considering the sphere center as the center of these axes. And rotation is also the degrees of rotation on all these three axes that the particular element will move. So it's just that you have the attributes and you have the values given to those attributes, and you have the box ready. Similarly, you have a cylinder, you have a sphere, and you have a plane that we thought of including. Now, what is this something called a sky, which I'm not really familiar of? Now, if I think of a VR scene, with a ground on which I'm standing. Now, all the four walls around me plus the roof make up my sky. Now, this is called a sky in a VR environment. Now, this sky can be either a plain color like we have it right here, or we can have a 360 degree warped image that can be spread around as like it is covering the whole sphere from top. So we'll see such examples later on. So for now, we just have the color for sky. So let's see how it looks in the browser when we play it. It looks like this, pretty basic. Now, I did not think of this when I was thinking about VR, right? So VR is usually these sophisticated graphics that play around. It's all really amazing to see VR. There are objects moving around, rotating around, and I can touch them. There are these things animating around me and all kinds of things. But this is really pretty basic. It looks like my brother made it on Microsoft Paint or something. But this is just an example to show you how easy it is to build even the most easiest elements on in VR. Now, does it mean that if I have to build sophisticated things, I need to write more code or maybe complicated code? No, it really is not that way. I'll show you why in a couple in some time. So basically, A-frame works in terms of an entity component system. Now, this particular sketch was drawn by Kevin Go, who is a developer with the Mozilla VR team and is a key player in the development of the A-frame framework. So he, uh, made this sketch. And what he's trying to tell here is there is an entity which is object in the scene. Now, all the objects that we built in our scenes, that is the cylinder, the box, and all those other elements that we included in our scene are called entities when you talk about VR, particularly A-frame. Now, these entities have components, which were the attributes that we gave to it. Now, these components are geometry, which we included in terms of the scale and position and size. And there is position, and there is sound or lighting, and the material or the color that you put on it. So, all these different attributes, which are the properties of the particular entity, make up the components. And every other, element that you want to include in an A-frame scene, A-frame VR scene, basically it works like this, that is in terms of an entity and component system. Now, how about we see a more real example, right? Now, we saw a very basic example, and that basically limits our thinking to imagine of A-frame that is capable of building just basic VR, basic 3D websites. So let's see if it can build something really close to what we've been seeing in VR when we've heard of it here and there on the web. So let me a scene that I built a couple of days ago. So can you see my screen here on the browser? Okay, great. So this is a scene I built when I was starting to learn A-frame. So I didn't have quite an expertise when I was starting to do that, obviously. But this is a scene, and what it does is it's just a 360-degree image which is covered in this particular scene, and I have these 4 different images of famous places around the world. And these are, if you observe, these are curved images, these are not flat. So if you see, they are in the form of a circle, right? And what happens if I happen to stop at one particular image, the whole sky changes to that particular place. So now I feel like I'm at this place called Horseshoe Bend, and I can basically see it. Now when I'm showing this to you in a browser, it looks really flat and it looks vague. But when you plug this in onto a VR headset and check it out, it really looks great. You really feel like you are there at that particular spot and having the fun of seeing Horseshoe Bend. So similarly, if I go to some other image, the sky is now replaced by the BC Palace, right? So let's see what code runs behind making this simple VR application. So as you see, again, it is just plain HTML, which I was talking about all this while. Now we can skip this head part because it's everyone knows this. And here we have included a downloaded version of the JavaScript. Hence, we are just giving a path to it for the source. And inside the body, we have the A scene right here. And inside this A scene, is the code visible and legible? Big enough? Yes? Okay, great. So basically, whatever we want to include inside the particular scene that we want to build, as I said, has to be included within the closing and the opening A scene that we are exactly doing here. Next, we have some images and other graphics that we have in our scene, as you saw. Now, it is a very good idea to store all these in between these 2 tags called A assets. Now, A assets is just a place where you can store all your images and 3D models that you want to include. So I'm just storing all the images, all the 4 images right here, and giving them an ID using which we can reference it later. It's just the same way that you build a usual website. There's nothing new except the custom made HTML elements that we are using for now. Now, next, as I said, we make use of this something called a entity. Now we can't imagine to have a custom HTML tag like an a box for every other element that we want to include. A box is a really frequently used element, and hence it was made as an entity. Uh, it was made as a component. So a box was custom element as such. But what happens if we want to make any other kind of elements which are not present in terms of custom HTML elements? We use something called a entity. Now, using a entity, what we are doing right here is building a camera. Now, what a camera is, as we saw in our scene, this particular ring shaped object is called a camera, using which you don't have to use your hands while you have placed your phone inside your VR headset. So over here, I'm just showing it you on a browser, and I can use my mouse, laptop's keypad to move around like this. But whereas if you imagine yourself wearing a VR headsets, it's really frustrating to take out the phone and touch on something and then put it back on and experience it. So that's the reason we have something called a camera, and we give it the time constraint. That is, when you know leave it on a particular image for say half a second, only then it triggers some action. So that's what we are doing right here. And we are triggering the click action in this particular entity. Next, I've just included the curved image primitive called the a curved image for all the 4 images that you see on the scene. And I've given an ID for all of those. Now, this is just the code, the complete code that was behind that amazing, probably amazing scene which you saw. So what is this sky that we talked about? So basically, when I go here first, if you remember, we had a grid behind it. So this grid is what I applied as my sky initially before I changed my sky to one of these, curved images right here. So I have included a little bit of JavaScript in this particular code because we want some action to happen. With HTML, it's just plain visuals, right? So what am I doing here in the HTML is I'm just, selecting a particular image, checking which particular image was clicked using my camera, and then applying that as the sky. So I'm just getting the element sky, and then I'm applying a particular image as a sky. That's it. So you go here, horseshoe bend, and the sky is changed to an image, a 360-degree image of horseshoe bend. You go here to Atlantic Ocean, and the sky is changed to a 360-degree image of Atlantic Ocean. These 360-degree images are really easy to make using simple hardware, as simple as your smartphone, or probably there are a lot of websites where you can get royalty-free images of these 360-degree images and 3D models and 3D 360-degree videos and things like that. So all these assets are available out there, free and ready to use in your scenes. So that's what was basically you know a VR application that was better than the first one that we built. So still, what we observed was it is just so many lines of code that is involved behind making even a better scene than the one I showed, or even the best game that was ever built using AFrame. It's just like a couple of lines of code, maximum like say 2 to 5 pages, and you have a complete game ready. How can we definitely cannot imagine such a scenario with the traditional VR applications as of now. Now the AFrame website comes along with a lot of features, and one of my favorites is something called A Registry. Now, what basically is A Registry is that it is a curated collection of AFrame components or shaders. What I mean by this is, you know, since it is an open source framework, there are contributors, there are a lot of fans of AFrame who build these components every time. So there was a box primitive that we used when we wanted to build our basic hello world scene, right? What happens if I want, say, a mountain? So here, as you can see, there is a mountain. But I don't want to write it as an entity by specifying all the attributes to it every time. I just want to have a mountain as a custom HTML tag, so I can use it every time. I can do that using the a entity and writing the code behind it, the boilerplate code behind it, and I can submit it to this a registry, which will be curated and made available for others to use. So when they include your JavaScript file from here, they can directly start using your custom made HTML tag inside the AFrame VR code base, right? Now, when the A-frame project was started, there were very limited components that were ported or shipped with it. That is, there were basic things like position, rotation, and basic controls, geometry, and things like that. But as I said, the fan base of A-frame is so strong that people started building their own entities and started submitting it to a registry and allowing others to use it. And right now, A-frame has so many other components available for use by the developers. And I'm sure as I'm talking to you, this is again growing, and some person out there is submitting another component to the registry which is being curated. So it's growing at a really fast pace, and it is the what I know it is as per what I know, it is the best way you can start building VR applications, the easiest and fastest way as well. Now there is also this particular tool available for A-frame. So when I enter an A-frame scene on my browser, if I hit this Control plus Alt plus I keyboard shortcut, I'm shown an inspector tool. Now what is inspector? It is basically a visual tool for A-frame which lets me modify or update the values of the attributes of the components present inside it right on the fly, I mean real time. So for instance, imagine this scene that I probably was building. So this is a Pokemon Go scene, as we all know, and I wanted that dragon to stand right on top of the Pokemon ball. But according to what estimates I made, the coordinates for the position that I put up in my code were probably not right, and it happens to stand a little behind. Now it will be really really frustrating for me if I have to go back to the code and do this trial and error with this positional coordinates and check every time, come back to the browser and check if the dragon is now at the right place. Instead, with the inspector, what we can do right now is I can just directly drag the dragon and put it at the right place, and the coordinates, the values of the attributes will automatically be updated. Okay. Now, let's talk about the various applications that VR and A-frame has in particular. Now, whenever we think of VR, we usually take it in terms of, entertainment perspective, that it may be used for, watching immersive movies or playing immersive games with controllers while feeling that you are the protagonist in the game or things like that. But in reality, VR has a lot more to offer. For instance, there is this ape painter which was released by Mozilla VR team a couple of months ago. What it allows you is when you put on HTC Vive and include a painter, it lets you paint in mid-air. So if you have artistic hobbies, it's really great for you to uh, have the feeling of being able to have so much of large space first of all on your canvas to draw. Next, you can move around your own painting and complete different parts of your painting, which is really cool, right? It completely removes the idea that a painting has to be limited to a 2D paper or a canvas, right? Next, we have data visualization, which is increasingly getting popular in terms of VR. Now, every one of us, no matter what we are working on, we have some data to be analyzed at the end of each month, right? And what if I could show my manager the data, the analyzed data in such a way that he was completely impressed by me? I can do that using VR. I can just hand him a headset. When he puts on a headset, he just sees all the values in the manner that is being shown on the screen. So he has three different access in which he can see the data, and he can move around the data and understand the data in a very quick and interactive manner, which is really good as far as I'm concerned. And definitely, it is increasingly growing in demand for education, particularly for medical education. Now, I definitely would not want a medical student to experiment something on real human body before he has enough practical experience. And if using VR, you can give him such an experience and let him know where a particular body part lies inside the body, or give him probably a simulated experience, an immersive experience of conducting an operation, he's really better ready for doing it in real time, obviously when he has the required qualifications, of course. Now, when we talk about virtual reality, we automatically tend to think about augmented reality as well. Now, augmented reality and virtual reality are almost, two technologies that are growing at really fast and competitive paces. So, what has AFrame to offer in terms of augmented reality? Now, AFrame's work in augmented reality is really limited as of now. They are just starting off with it because they're mostly concentrating on enhancing the experience with VR. So, with AR.js and AFrame, you get an augmented reality experience with AR as well. But in case you are interested in augmented reality, you might want to follow up with AFrame's website, because that's where uh, AFrame's website and the blog, because that's where the news will be shared if the augmented reality is the experiment on augmented reality is moving forward. Now, the community that we talk about in AFrame is tremendously big. There are more than 125 contributors on the GitHub repo of AFrame, and more than 5,000 stargazers. So there is this tremendous community, and I keep repeating this. There are not contributors to AFrame, but there are fans to AFrame, because they really love the easier way in which you can now start building some a technology which is as cool as virtual reality, right? Now, there is a Slack channel on which the community usually communicates, and there are more than 3,000 members on this Slack channel. And you can log on to it if you're interested in, getting in touch with the contributors and the Mozilla VR team, which is also present on the Slack channel. There are different channels on this particular, Slack team, which are dedicated to different kinds of audience and different kinds of developers, and based on what you're trying to explore in the AFrame. And AFrame also releases this blog every week called A Week of AFrame, which contains all the news, all the updates that happened in the past week. Now, if you can, now as I tell you, this blog is released every week. You can really imagine that there would definitely would have been a lot of updates that have to be shared every week. Otherwise, it makes no sense to have a weekly blog, right? They could have had a monthly blog if the updates were lesser. So that's the pace at which it is growing, and that's the tremendous amounts of updates they have to share, right? And there are hundreds of featured projects. Probably, if you're inspired enough with this A-frame and you happen to build one, amazing scene for yourself and tweet it to A-frame, it might be one of the next, hundreds of featured projects on the blog. That's all on my part. Thank you very much. I would like to take any questions if you have.
Chick, 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 cheer. Okay, so yeah, if anybody has any questions, I think you'll have to come up here because the microphone is being used from the computer. So I don't know. Does anybody have any questions you want to come up? Come on up. All right, we got a question here.
So while I was showing my slides, I didn't get a chance to look at the audience. So I was kind of feeling like I was talking to myself.
I know.
Hey, hi.
Yeah. Hello. There they are. All right, here you go.
Okay, so in the what looks like a open source like asset store or whatever, what are the technologies like as far as creating those assets? Is it like are you doing that in the HTML like A-frame thing or whatever it was called, or is it more of like a OpenGL shader experience kind of thing when you're actually like creating that like Charizard for the Pokemon thing?
So if I get your question correctly, you're talking about the A registry in which the contributors contribute their own entities, right?
Yeah. So like, or like a custom like texture or, yeah.
Yes, so that's what we're talking about. It's all simplified. It's HTML or at the max some JavaScript involved, because it's the JavaScript which you need to include in your HTML file at the end of the day. So it's just JavaScript with a little bit of HTML that you use to build these entities and make it available for others to use using just a custom HTML tag. So again, it's tremendously easy, right?
Cool. Yeah, and I guess the only other thing is like, does that also, is it just similar to everything else where you'd like model an asset somewhere else and then bring it into this and that kind of thing?
Yes, definitely. So as I showed you this curved image, there was an image which I placed in my scene using the element called a curved image, right? If you remember. So similarly, we can have 3D models placed in the scene at a particular position, just like that using these HTML tags. So there's nothing more. So if you happen to be a graphics designer, you can also design those models yourself. But if you just happen to be a developer, you can take one of those models which are available on one of these open source websites and then include them in your scenes.
Thanks.
You're welcome.
Any other questions? Yay, nay? Come on up. Come on up. Another question here.
So traditionally, real-time, hey. So
Hey, hi.
traditionally, real-time 3D is always been kind of an application domain where performance is like considered, really important. JS is already kind of slow, and I was just kind of wondering, does AFrame add a lot of performance overhead beyond using Three.js directly, or is there some kind of bootstrapping point where that's kind of made negligible? From parsing it.
Right. So about the performance constraint, what AFrame basically does is, if you, while you're playing AFrame in your browser and you happen to open and check the console, you see that the HTML part is not updated. So AFrame basically skips that part, which forms the most overhead for these VR. So it does not let the HTML update and lets you get a real-time experience of this VR scene using the sensors which are in your mobile or on your VR headset. So it minimizes that part completely.
Okay,
did that answer
and
your
what
question?
about with sort of when you're manipulating objects within the scene, when you're doing rotations, changes of positions, maybe changes of textures, do you know if there's much, is it inefficient to do things that way through AFrame? Does that like impact performance by going to the DOM, or how does that work?
No, basically they take care of the performance part in the boilerplate code that they write behind AFrame. So all you have to do in the front end part is just include the elements.
Okay.
So there is some part of performance overhead that is involved with every kind of VR that we talk about, because there are a lot of graphics involved. But then the fact that JavaScript or HTML leads to that thing is completely minimized.
Okay, thanks.
You're welcome.
Any other questions? Time for one more? Yay? Nay? All right. Everybody give a round of applause. Thank you. Appreciate it. All right, appreciate it, Srushtika. We'll see you next time.
Sure.
All right.
Thank you. It was really
Bye-bye.
nice meeting you all.
Everybody say bye.
Bye bye.